Okay, hello. This is 9 p.m. in Japan. I am going to start tutorial live now. I'm not. Let me know if the sound is okay or not. Right. So, thanks for coming. This is the 42nd episode for Houdini Algorithmic Live, and today's topic is to create a animation looking like this to create like night cityscape animation like this using several techniques today. So the process goes for today is to first create a city grid starting with a really small one like 20 by 20, then use a algorithm called wave function collapse, and there is a node in Houdini where you can use this small sample to create a large grid like this. Okay, so I'm gonna use that to create a really big city grid. Then after that I'm going to extrude it to build a building like this based on the area of each primitives or faces. Then also create some window shapes, and then the last I'm going to animate it using the frame values so that it will look like it's being lit from 0 to end. So that's the goal here today. The flow is pretty simple, nothing really special here, but I wanted to try out this wave function collapse. Comes from the Houdini Labs node, so it's kind of a practice for me to use how I can use this. And also I wanted to visualize one of the graphic that I found really interesting, which is from this website. The graphic from Richard Giblett, and there is one graphic that I liked a lot, which is this one. So I wanted to mimic this kind of graphic myself using procedural process using Houdini. So that's the goal here, and this is kind of a result that I get. Not bad, I think. And I also animated this since we're using Houdini. Right. So that's my goal here. And before we get started, I'm also would like to introduce the introduction to the wave function collapse algorithm, which there is some explanation in a website specifically for Houdini. In this page, in this video, I found out about this how I can use this wave function collapse node for Houdini from this video. Coming from Houdini, a wave function collapse supercharged with PDG for level generation by Paul Ambrosiusen. So this gives me a lot of information how I can use this node and what it can be used as an example. Most of the cases he shows how you can use it for dungeon generation, but in my case I'm going to use it to generate a city block, or it could be used for any kind of purposes, I think. And so if you want to know the detail about how this algorithm works, you should go to this video to check it out. It's an hour long, but it's worth it. Okay, but this time I'm going to just show you how you can use it without explaining much of its algorithm. Okay. All right, so let's get started. To start off, we have to start by creating a small grid, a city block for sampling for a wave function, a collapse algorithm. And that can be really small, like 10 by 10 or 20 by 20. I will start by a 20 by 20 grid to use it as a sample. And I would like to make it as a procedural grid, but to test it out, I would like to first create a pseudo grid or simple grid using image tile or a PNG image. So first I'm going to like draw some like random grid here in a Photoshop, then save it as a texture, save it as an image file, then try to use it as an initial test to create a big city block. So I'm just going to use black and white, and this is the resolution is 20 by 20, and just going to create random block here. Okay, hello everybody, and see how this works. Okay, could be any kind of grid actually. It might be interesting to have like L shape as well. Like this, like this. Might want some small value here. Okay, that might be too big. Doesn't really matter. I mean, could be really random. Maybe let's go without L shape, because L shape, it's a bit difficult to treat with L shape, so, which I am going to deal later on. But for now, I am going to deal with only the squares. So let's do this like this, and for this one, okay, almost there. Maybe I would like to have a width at least 2 pixels. Okay, how's this? Let's have this here, and okay, so let's have this as a base sampling image, and say let's save this as a 20 by 20 pixel grid on the desktop, and I'm gonna make it as a PNG file. Okay, so I'm gonna say grid. Right now, and let's have this file also saved on a desktop. Then let's start building it. Now, in order to, first of all, in order to use the wave function collapse node, you gotta go to gotta open up the shelf to access the SideFX Labs node, which is right here. And I am going to use the version 18.5. Okay, and if you open that node tab, you'll be able to see a bunch of node here. If you click this button here, you'll be able to update the labs node to the latest. So let's click this update. And if it's the first time you do this, I think you gotta reopen the Houdini. All right. So, okay, use X to swap colors in Photoshop. No need to sample any of that. Okay, thanks. I don't really use Photoshop myself. That's good to know. Thank you. Right. So now, after I have updated the SideFX Lab node, you'll be able to see under the Labs node and under some utils, I think. Yeah, not utils. Utils, you'll be able to see like Labs WFC sample plane, WFC initial grid, and so on. WFC is the word for wave function collapse. So I'm gonna first create this WFC initialize. So this is going to be used to create the grid that I'm going to sample, and also as an output value. I'm going to duplicate this one. One will be the output size, one will be the input size, input grid. And also I'm going to use a WFC, the name is called Labs 2D Wave Function Collapse. This is the solver node to actually calculate the wave function using the wave function collapse to create a big image out of a small sample. Okay, so for the right side grid, I am going to import the image with this one, and there should be an option to use the texture. So click this from texture, and I'm gonna choose the one that I have saved, which is under the hip directly. And what was the name? Grid.png. Okay, so it will automatically initialize using the image that I imported into a grid. In this case, I have imported the 20 by 20 resolution image, so we'll create a 20 by 20 grid. And if you look at attributes, the new attributes being created is these colors and these names, and those 4 values are the important attributes. Later on, if you want to create your own grid by yourself procedurally without using image. Okay, so for the left one, I'm gotta have to set the size of the final output. Now let's make it really big, like 100 by 100. Maybe that's too big. Oops, I made it 100 by 1000. So 100 by 100. So what I want to do is to sample the information from this grid and use that sampling information to build a bigger grid. And you can set the size of the sample, like the default value is 3 by 3, meaning you are going to sample 3 by 3 grid, 3 by 3 grid from the input image. First this one, second this 3 by 3, and third 3 by 3 grid, and so on. And use those collected information to build a bigger image using those information and using the probabilistic functions or algorithm. Okay, so but you don't really need to worry about that kind of detail of the algorithm. This solver will just do the job for you. You just need to set a search pattern size, pattern search size, which is the number of samples you want to use. More sample you have, more CPU time you need, but more bigger grid structures being preserved. If you have small numbers, then smaller structures being preserved, so the output gets more randomish. But for now, let's set it to 3 by 3, and for the output, we're going to connect it to the first input, and for the input sample image, I'm going to just connect it to the second input. And as soon as you do that, it will create a grid pattern like these so easily. Right, and you can change the pattern by changing these seed values. Takes a while, but we'll create like this. Now if you make it 2 by 2, it'll create a bit more randomish tile like these, because it's sampling less images. There's all these patterns are probable using the 2x2. If you make it 4x4, then the calculation cost is really high, but you'll be able to use a bigger block. But sometimes it gives you an unwanted result as well. So it depends on the image you want. In this case, 4x4 made these some of the rectangle too big, like you see here, so might not be suitable for this purposes. So let's make it 3x3. Okay. But later on, if you want to make those grid like L shape, 4x4 starts to get useful. So remember that for now. But for now, I'm going to go with these as a base. And in order to replace this small grid sample with the procedural process, I'm gonna keep that later. I'm gonna keep that to the last one. First of all, I would like to just try to create the base geometry for the building. Okay, which is not going to be that hard, I think. Okay, oops. Now it seems like if I change the frame, it also updates the wave function, which is not what I really want. But let's see if we could prevent that. Now to try this out, I'm going to keep the output a bit smaller so that the calculation will be faster. So I'm gonna go 50x50 for now. All right, and then since I would like to build a building, since it's black, it's a bit hard to see, but there is actually a point right here. So I'm only going to retrieve the points, which is the black one. Okay, so oops. Okay, what I do? Okay, so first of all, I'm going to use the delete node to get only the points which the color is black. And to do that, I'm going to use the filtering to check the CD attribute x is equal to 0. And then use it for points, and I want to retrieve that, so delete non-selected. Okay, now I have got the center points for the grid for the building part. Now I am going to create a single grid or a square, the size of 1x1 and no split lines. And what I'm gonna do, I'm just going to copy this single grid to the building block points. Now all those points have been saved to each of the grid points. Now it's a bit hard to see, so I'm gonna make the background light. Okay, now it's better. Now it already looks good. Now what I want to do next is to do the extrusion, but before doing that, currently there's too many points here, which is not really necessary, especially the one that's inside here. So let's dissolve that first. First thing I will do is to fuse to connect all those merged points or overlapping points. And then I'm going to use the divide node to make it to remove the shared edges so that you only have the outline points and all the inside points will be disappeared or dissolved. Okay, now what I am going to do now is to measure the area for each of the primitive, and based on this area I'm going to set the height of each primitives, which doesn't really matter if you make it random, but I'm just going to keep some rules here to set the height of the building based on the area. So if the size is, the 2D size is big, then the height is also big. Okay, so let's do that by first I'm going to create a measure node and set it to primitive area, and for each primitive now you'll be able to have those areas, and based on those values I'm going to set the height of the building. Okay, now let's do that by using, since I would like to access each of the primitive attribute and set the height for each primitives, I am going to use the primitive wrangle. I mean, you could also use like for each loop as well, but it's going to be a bit, the calculation is going to be a bit slower, so I'm gonna do it this primitive wrangle way to make the building, the extrusion procedurally, so that you could also create a size for the windows as well at the same time. So let's name this extrusion. Let's open this editor up by Alt E. Right, now let's do this. First of all, first thing I would like to do is to retrieve the area from the primitive attribute for, so do like this, and then I would like to calculate the height of the each of the primitive for each of the building from this, using this area. So let's name this H, and I'm going to use the power function with the area with some power value. Like I'm gonna create a parameter called pow, apply, accept. Okay, so, and also promote this parameter. So by changing this, you'll be able to specify how this area being affected with the height. If you have high value, then you have more area you have, more height you'll be able to have. Less value you have, less effective with the area and the height. Now that I have those information, let's start building. Let's start doing the extrusion procedurally. Now, first of all, I'm going to retrieve a point list from the primitive using prim points, which this will give you a number of points here. Now, I can loop through this point list and access to the point position. First of all, I'm going to retrieve the point number for each point, and then get the point position for each of the point number, like this. And then if you just want to raise this points upward with this height, what you can do is just create a new position plus set 0, height 0, then create a new point t at point 0, and pause, and use those points to create a primitive, add new primitive. So and prim at prim 0 poly, and add vertex at this newly created point into this empty primitive. Alright. Now all the height seems equal, or may not that difference. I mean, there are some differences here, but it's not really big of a difference. But by raising this value up, you'll be able to see more differences based on the area. Alright, that looks good. Alright, so next thing you want to do is to create a side of this building, I guess. So let's also do that. And in order to do that, you need to have a list of points, which is this one, together with the PTS right here. So this is the original points here, this is the newly created points. And by having two point arrays, you'll be able to create the side using for loop. So and PTS add using array. Alright. So yeah, I have a question, why not using polyextrude with descale control? Well, that's because I would, as I said, I wanted to create a window on the side. At the same time, I create the extrusions by using some additional attributes that I'm going to create later. So that's kind of why. But I guess you could also do that as well, maybe with some of the process. But let's just do this way. I mean, if you know the easy way to do that, it's yeah, you better do that way. I guess I'm doing the hard way, hardcore way. Right, kind of am I practicing the vex as well, I guess. Alright, so what I want to do now is to add or append this NPT that I've created to the new array here. Now let's create the side using a for loop. And then access to a 4 points to create the side. So PT1, and PT2 is from the PTS I plus 1, and calculate the remained using the PTS. PT3 will come from the MPTS I plus 1 modulus len and PTS, and in PT4 and PTS I, and I think that's the 4 points that I need to create each of the side for these squares. So after I have it, I can create a primitive polygon. Let's name this side poly. Add prim 0 poly. Oops. PT1, PT2, PT3, and PT4. Alright. So now that I have created the extrusion like this, but this is not enough actually. What I wanted to do is to create a window-like shape, which looks like these. If you zoom this up. So if I look at this geometry carefully, this is like a silhouette, but it actually have a grid of windows on each faces of the building. So just by having a one full side for each of the building is not enough. I have to kind of split this building into layers and also in the vertical direction as well. to create a bunch of windows. Okay, so let's try to do that using same vex functions. Now, first of all, I would like to define the number of layers on the height direction, and for this example, I'm just going to keep the layer height, each of the layer height to be equal to 1, which is the same size as the grid, single grid size. But you can make it like varied by using random. But for now, I'm gonna make the height as 1. So that means this height itself is actually going to be the number of layers. Now, currently the calculation result for this one is not really an integer, so to make it to be able to use each layer's height to be 1, I'm going to make it first of all an integer value by using like ceil or round or int or floor functions. I'm gonna use ceil to get the ceiling value from the floor value. Okay, so now the building height will be clamped between the 0 to some integer value. Okay, now next thing I would like to do is to create each layer's point using this height value as a number of layers. Okay, so let's do that. And to do that, I am going to create another loop besides this one. So first of all, I'm going to hide this one. Okay, and create a new loop. Let's use n as an attribute, and h will be the number of layers. Okay, and since I already have the first layers, okay, let's also hide these as well. Okay, let's hide these top plane as well. And currently I only have the one that's on the bottom. So what I want to do is to copy this the grid of points upward by a number of layers. So I already have the bottom one, so I'm going to keep the start from 1, which I'm going to use it as a height, and then smaller than or equal. Okay, so use this kind of conditions. Right. Now I am going to copy all these values here inside this one. Okay, and then let's create a point here, and let's see what it does. I don't really need the primitive for the top part, so I'm going to remove this one and this one. Okay, and I think I also need to set the height for each layers, which is defined right here. So I should replace this h with n, which is this one. So let's set it to n. Okay, so now I have a bunch of points which explains the layers of a layer for the building. Okay. Okay, I have a question. Is your Twitter mainly for Japanese audience? Well, I'm not sure. I tend to tweet in Japanese, sometimes in English, but since I'm Japanese, and Twitter is to tweet what you think in mind, I guess, so I think in Japanese, so that's what I tweet. Right. Where was I? So next thing I would like to do is to create a face for each of the layers, like this one, this one, and this one, and this one, so on. Okay, that's what I want to do next, using all those points information. Now to do that, you see that this is a, if you look at the side, if you focus on the side, this is a 2D grid. And in order to create a face for each point using all those points, you need to first get the horizontal point grid and also the vertical point grid. Now, unfortunately, there is no double array structures in Vex, as you might know already. And if you have that kind of structures, it will be pretty easy to build this kind of 2D like grid using a preserved arrays. But since we don't have that, what I'm going to try next is to use a new data structures introduced from Houdini 18.5, was it? Called dictionary. So I'm gonna use that dictionary as a practice as well to use it like a 2D array or a multidimensional array. Okay, so let's do that. So first of all, what we would like to do is to create a dictionary value for each of the layers. So the first layer for the first layer, for the second layer, third layer, and so on. And for each of the layer values, I'm going to store the array, just like I did for the NPTS and PTS. Okay, so the dictionary works for each layers, and inside the dictionary, each of the keys, I will store these, the set of PTS and NPTS to create a site like we did last time, right? I hope it makes sense. Now let's try to think what kind of structures we could make. There is some limitation with the dictionary. You could have a array value inside a dictionary as a value, but you cannot have a array of vectors. You can only have array of float or integer or string values. So you cannot use a vector value, meaning you cannot create an array of positions. So but I do need a position information in order to create a side information, side faces. So what I'm going to do is to deconstruct the point position to X, Y, and Z. Okay, this might be cumbersome. This might sound really cumbersome, and there might be a better way to do this without using dictionaries, but let's try it. See if we could use this dictionary in real practice. Okay, so I am first going to create a dictionary value using dict layer, right? And let's set the, wait a minute, maybe I should create a well, let's name this the root dictionary name, like PTS dict, which since we're going to store the points information here. And initially we have only the bottom plane here, so I'm going to start with the 0, which I am going to use it as an indicator to define which layer we are in. So 0 means is in the first layer, the bottom layer, which is drawn as black right now. Okay, and for this one, I am going to store the some additional values, like let's call this layer, and I'm going to create another dictionary called layer, which has several information in order to define these values. One is the point number, and one is the point position information for each of the point. So another dictionary to start off. First I have this ptnum as a key and pts, which is the point list, point array for the bottom part, which is this one. And another key is the point position for x, y, and z coordinate. So the x for the point x, and wait, is that correct? No, we cannot use this one because we are in the primitive wrangle, so we have to retrieve the point attribute here. Okay, so in that case we need a float x array float y array for the point and float z array. I'm going to loop through all the point number, get the point information, then get the position for each point for primitive, and then append this x value to xs array, and do the same for the y and z to initialize this array so that it has the same size with this pts. Okay, so ys, zs, position z and position y. Now I can now have a key for the x and y and z. Right. Okay, starting to get a bit complex here. Start to make sense later. Okay, now that I have this layer, which is supposed to be created for each layers, and this is for the first layer actually, and I'm going to use this first layer as a initial value for this root dictionary. All right. Now let's apply and see if I have any errors. Nope, looks good. Okay. At this moment, I have just created the first layer, so next thing I would like to do is to create the layer information for all these newly created points, right? And each layers we are using this for loop, so this is where we want to create another layer, right? So right after we have calculated or created this NPTS, I'm going to create a new layer. Oops. Let's name this dict and layer set Okay, I have a question. Just came in and realized I missed almost an hour of the stream. Will the stream be uploaded to be seen later? Yes, this streaming, the live stream, is going to be recorded and also be archived so that you can see anytime you want later on. And I'm also going to upload the file that I've created during the course, during the sessions, after I have finished this, and you can access from the video description page, so don't worry about it. Okay, now for the layers, the up top, the layers that has been created using for loop, I need to have the same key, the ptnum, x and y and z. So for the ptnum, this is going to be npts that I have just created right here, right? For the xs and ys and zs, we kind of need to create the similar stuff like we did here inside this loop. So I'm going to copy this one and maybe paste it like next to, right after this npts array. And let's also rename this attributes to and X and Y, Z, because this same name has already been used here. So, and also we need to do some similar things with doing here, appending the value, the X, Y, Z coordinate to these float arrays. So let's do that right after, right here. Okay, and the name of the array was NXS, NYZ, and ZS. And we also need to change this position name to npos, npos, npos. Okay, which is this one is the position for each layers, for each point. Okay, now apply. Oops, now I seem to have some errors. Okay, this is the one. So I need to set I need to create the layer, the new dictionary layers for the X, which it's going to be NXS, for the Y, NYS, and for the Z, NZS. Okay. Right. Now, after doing it, what I need to add this layer as additional, with the additional key to this root dictionary called PTSDict. Now previously I was using 0 as a key for the bottom one. For other one, I'm going to use the key coming from the number of layers, so which is equivalent to this n value. And in order to use the dictionary, you need to change this to a string. So I am going to change this n value, which is an integer, to a string and use that as a key. And to store into a specific key, what I can do, first name PTSDict and change the n value to string using I2A, then store this n layer into that dictionary key. All right, apply and check if there's no errors. Okay, that looks good. Now the preparation is done in order to access the necessary information to create the faces. Now that was really long. Now next thing I need to do is to access each of the point information from this dictionary to create a faces, just like I did here for each of the point list. Okay, so let's do this. First of all, I am going to access to each of the dictionary value and to add or to create the faces. And the number of layers that I have to refer to is if we have 1, 2, 3, 4, 5, 6, 7, 8 layers, then we only need to loop through 7. We only need to loop through 7 iterations. That is because we are going to use the first layer and the second layer to create the face. So if you have 8 points, you only have 7 faces. So that's kind of a reason why we need 7 layers, which is the number of dictionary values minus 1. So for loop length, let's use n, and until the length of PTSDict minus 1. Okay, now let's next thing I would like to do is to access to this layer information for n equal to the the integer is equal to n, and also n plus 1. Okay, so layer 1 is PTSDict n, and dict layer 2 PTSDict n plus 1 modulus length PTSDict. Or maybe we don't need this because we don't need to loop through the array. Okay, so And we also need to change this n into a string, since the key is in string. Right. Now that we have a 2 layers, we can access to each of the layers to create a faces. Now, just to create the face, we only need to access those PTS information, which is inside a PT num key. So let's do that. So int PTS1 array is layer 1 PT num. Int PTS2 layer 2 PT num, the same key. Okay, now that I have 2 arrays, we could use this code that we use to create the faces between 2 point arrays. And one was for the PTS2 and one was for the PTS1. So PTS1 and PTS2. So replace these numbers and this one as well, PTS1, and this can be PTS2. All right, so let's see how this goes. Apply and yep. So the side has successfully been created, and if you show up the edges using a shading, smooth wire shaded, you have created those square values. Right, that looks good. Now what I'm going to do next is to create a window faces. And if I look at this graphic here that I'm referring to, some of the windows is wide on the X direction, some of the window have a long size on the Y direction. Okay, so I want to differentiate the size of the window looking like this, and also some of the window looks really long on the horizontal direction. So that might also be something that I could control later on, but for now I would like to first control the size of the window on a single grid. Okay. So to do that, first of all, we could try by creating a uniform scaled size window from each of the faces. Okay, and you could do that by accessing to the one that I have already applied as a dictionary value, which is this X, Y, and Z value, which is the X value here for the X, Y, and Z value for each of the point to create the faces. And use that information to calculate the new point position to create a window size. Now, if you just want to have a uniform scaled window, it's better use poly extrude. But if you want to differentiate the value for X and Y for each of the faces or each of the building, control it using attribute with the X might make more sense. Okay, so let's try to do that. So the position where I can create those points for the windows, it could be somewhere around here, and maybe somewhere right after we have got the point numbers right here. So what we want to do is to get the point information, the point position information, which corresponds to these values here. But we cannot use this point function to use the PT1 and PT2 to access to a @p attribute. That is because those points has been created previously using this for loop and doesn't really existed previously. So if I try to access to each of the point like this, you can only access to the phone information which existed previously, which was the bottom part. These points which has been produced procedurally inside the code cannot be accessed through this point function, which I already tried and didn't work well. So that's kind of a reason why I have stored this x value, which to store the point position when we have created the new point. Okay, so let's retrieve that x, y, and z position to create a new point. Right, so that's kind of a let's first create a vector pos1, or no, actually it's a array of floats, so I gotta do like this. So the xs1 is layer 1 x, float xs2 is layer 2 x, and do the same for y and z. Right, so y, y and z, and the key is also z and y. Alright, now inside the for loop, since the length of this array is the same with the x array or either of the arrays, so we can access to each of the array with this pt number right here to get the point position. Right, so create a vector pos1 corresponds to this one using set, and for the pos1 which comes from the pts1, which corresponds to the xs1, ys1, and zs1. So I'm going to copy this one, xs1, and inside the index, which should be equal to this one here. And since this index is a bit long, so let's create the shortcut for the indexes. So if, let's say, id1 is I and int id2 is equal to this value here, and we'll replace this with id1, id2, and id1. All right, now do the same for this one, xs, ys1, id1, cs1, id1. All right, so that's for the position 1. Do the same for position 2, 3, 4, 2, 3, 4, and this should be id2, 2, 2, 2, 2, 2, and this should 2, 3, 2, 3, 2, 3, and 4, and 4. Oops. Nope. I think I made a mistake. This should be xs1, 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 2, 2. Yep, like these. Okay, it looks a bit confusing, but hopefully, okay. Seem to have some errors here. Right, where is that? Candidates are float vector int. Okay, so where did I do wrong? 8040 s. Okay, so this one sounds wrong. Let's say, let me give these. Okay, this should be comma. All right, So I need to replace all these with comma. Alright. Okay, so now that I have a position for each of the faces to create a square face on the side, now we can start creating a window. Now let's try with the uniform size. We can retrieve the center position of this 4 points by adding all those positions and divide it by 4. So let's do that first. Vector center position is pos1 plus pos2 plus pos3 plus pos4 divided by 4. That will be the center point position. Now use that center point position to create a scaled point for each of the side. Now each of the points at the vertices, which is these one. Now, it might be better to do it in a loop, since creating one by one makes a lot of coding. So what I would like to do next is to create a array of vectors to store all these positions. I'm gonna name this like W positions, and inside the array I'm going to store all these point numbers, positions. Okay, now let's loop through all these using another loop. Okay, I realize the code start to get really long. Alright. Just to make it flexible. But I guess it will reward in the end. Okay, for the position 2, I would like to get the... Do I need to? Oh, no. I actually don't need to get the second one. I just need to get the first point position for each of them. And then what I'm going to do is to scale each of the point based on the center point position. So let's say the new window position will going to be a center position plus a W position minus center position multiplied by some multiplication factor like 0.5 will make a half size squares, should make a half size squares point positions. Now after I have retrieved the new point position, I can now create a new point at right here. WPT is equal to at 0.0 W new window positions. Okay, if I look at carefully, if I show up the point, the new point has been created inside a face. And if I change this 0.5 to something different like 0.3, I now can be able to uniformly scale the size of the window. Now I actually don't want to relate this size of the window based on the uniform scale. I want to differentiate the value for the horizontal direction and the vertical direction. So I cannot just do something like this, but I gotta make it a bit more flexible to be able to differentiate the scale for the 2D or XZ direction and the Y direction. Now to do that, let's say we have two values, one for the horizontal scale, let's say 0.3 for random value, and VS for the vertical, let's say 0.7. Okay. and try to use both of those values to scale the point on horizontal direction and the vertical direction. Now to do that, we kind of need to deconstruct this directional vectors into x, y, and z and multiply each of the coordinate with these values. So first I'm going to create a directional value, which is a w pos minus c pos, and I'm going to recreate this directional value using these scalar value. So w direction is equal to set for w dir dot x, w dir dot y, w dir dot z. And each of the x, y, z value I'm going to multiply either one of the values. And since we are dealing with the xc plane as a floor, ground like plane, and the y direction as a gravity direction, I am going to multiply the hs, which is to use for the scale for the xc direction. So I'm going to multiply with x and z, and for the y I'm going to multiply with vs. Alright, now I am going to replace this one with w direction and see how it goes. Okay, now the scale has been changed based on these two values for this point, and currently the horizontal scale, which in this way became 0.3, so this is the size of this point inward using as a window is a 30% size of this original length. For the height, this is 70% height. Okay, so I can change that to 0.1 to make it more smaller and the vertical, and like this. Alright, now that looks good. Now later on I'm going to make it as a random values for each of the y and x value. Okay, so but for now let's have this as a parameter, chf hs and chf vs. Okay, and let's change these parameters. Let's promote the parameter and have some values. Okay, now next thing I need to do is to open up or create a edges so that I can change the color of this window. To do that I need to create a 4 side faces using this point, this point, this point, and this point for each of the side. So in total we need 4 frames as polygon for the window. Okay, so that means we need to do another for loop, which in this case we already have the point numbers here, but we don't have this point number being applied into an array, which is necessary to do the connection with these point numbers, the list of points retrieved right here, which is these point information. So let's create another array, int wpts to store all the point numbers which has been created for the window, which is right here, wpts wpt, and together with this we need the original point, which is this outside point numbers being stored in the array for convenience. So int opts array, and since these points are not in the array yet, we need to store that as well. And for these ones I can just say pt1, pt2, pt3, and pt4. Right. Okay, so now that we have two set of array, it's time to create the side faces. So I'm not doing another for loop through the WPTS. Okay, and get the OPT from the OPTS first, and also WPT from the WPTS. Now for this one, I need to have a next iterations as well, the next index as well, since we are looping through all those 4 points, but we need to have the next point information to create the side as well. So let's name this the first one OPT1, and the next one OPT2, OPTST plus 1 modulus length WPTS. Okay, so this should be T for what, WPT1, and WPT2 T plus 1 modulus length WPTS. Okay, we're almost done. We're almost ready for the window. Now we have those 4 points to create the side. We can say prim add prim 0 poly OPT1 OPT2 WPT2 WPT1 and see how it goes. Now, did it create a side? I think so, but it has the original faces right here, which is not really necessary anymore, which is this one. So let's delete this one, and here you go. The same rule has been applied to every faces of every building. It's a bit look weird because all of the building has the same width and height values, but it's working. Okay, I would like to also have this inner window area as a polygon as well, then make it as a different group so that we can access to this later on to set the colors. So let's create that, and that will be easy because these points are stored in this WPTS. We can just use this to create another polygon. So let's show this points up again for the side, but instead of using those point numbers, I'm going to instead use this WPTS as a list. And here you go, you have created an inside polygon, and I'm also going to set the group for this inside window polygon using set prim group 0 window. Let's name this wpoly 21, and for the one that's on the side, let's set this group as a wall. So set prim group 0 wall prim 1. Okay, all right, now finally, I don't want to make all these windows have to share the same values for each of the building. I want to make a difference for each of the building. So let's create some random values and for each of the faces. So to do that, we could go to the top part of the code and create 2 random values, one for the horizontal value. Let's say hs is equal to random based on the point position of the primitive plus some constant values. And since this will create a random between 0 to 1, and we don't really want to have a 0 value or 1 because that's going to make the window too small or too big. So let's clamp this value to some with the minimum values here. So I am going to use the clamp. And let's also have this minimum value as a parameter as well. So min scale, and clamp this with a min scale as well as the 1 minus min scale. Do the same for the VS, but this time I'm going to change the seed value. I mean, you can also parameterize this to change to see some different values for each of the building, but I'm gonna make it constant for now. Now, let's also replace this, comment this HS and VS out. And now all those windows are using the different sizes. Let's also promote the min scale and raise this up to control the clamp value. Maybe 0.3 is a good number. All right, that looks good. Okay, now that was a lot of code, but I think I have done what I wanted to do. Now I am still missing the top part right here. Now, since we have done all these with the code, let's just create the top part with the code as well, which isn't that hard to do, I think. So what we need to do is to retrieve the point list number for the last layers. And to get the last layer information, we could access to the dictionary that we have created, which was this one. So first of all, I'm going to retrieve the last layer dictionary from the PTS dict, the loot dictionary value, and we can access to the last key value, which is by converting the length of the PTS dict -1 into a string. Okay, now this is the last layer information, and we can also get the last PTS value, the array of points from this layer dictionary at ptnum key. Now we can use this to create a top polygon at prim0 poly tp last PTS. Okay, missed it. Alright, didn't work. Now what was wrong? Okay. Oops, yeah, showed up. Okay, so that looks good enough. Now I'm going to do another things to set the size of the horizontal grid size. Currently all the grid size is uniformed, it's equal to 1, so it's not really that interesting. To make it a bit more randomish, or to have more longer horizontal scales, I'm going to do that later with some additional process, but for now I'm gonna keep it like this and first create the animation. And to do that, wait, first of all let's look at the point attributes, and there is some information for the colors. Now we don't want this color information for the point, but I want to have this color for the primitive so that I can set each primitive's color. If we have like point and primitive attributes, the name CD, then the point attributes be used instead of the primitives. So we need to delete this attribute value for the color. I'm going to use attribute delete to delete the point CD. Then I'm going to use a color node to set the color for the window. So set the window color with, let's say, white. And for the walls, I'm gonna set it to black. And I forgot to set this class to primitive. Okay, and I wanted to set the top part as black as well, so I forgot to set the group for the top part. Go back to the extrusion and set prim group 0 wall. I mean, this is not really a wall, but let's just say it's wall top poly 1. Okay. Now, initial setup is good enough with this one. Now, last of all, what I would like to do is to animate this color of the window based on the time frame as a basic setup. Okay, kind of taking a lot of time. I wonder why. Okay, seems like this solver for this 2D wave functional collapse is called for every frame if I move this frame, so I don't want that since I'm not using any frame values for this 2D collapse functions. Now let's see how we can prevent this being called for each frame. Now let's see. Is there any values here that we could set? I am not sure. Maybe not in here. Is this related to right here? Maybe not. This one. Nope. Manual, it's okay, but this if I set it to manual, all these updates is not going to be done, so that's not a good thing. If I do auto update, oops. Okay, I crashed it. Let me go to the temporal folder to check. Alright. So oh, didn't quit it. Okay, well, it's still running. Wonder how I could prevent this to run for the time. I mean, it wasn't running when I was working previously. So, oops, again, but didn't. Okay, let me see. Let me know if anybody has some information how I could prevent this to run each time I change the frame. If not, maybe I can just cache this result as a file cache. That should be possible. Well, each time I try to change the frame, and now it crashes every time. Let me reopen this. Okay, and if I change the frame, I think it's still calculating. I can say that because if I change this to 100, I now see the solver right here. If I change the frame, yeah, I keep seeing this solver running, and that's not really what we want, is it? Because we are not changing any of the sources right here. Okay, okay, this might be a problem here. Let's set it as real time. I forgot what I needed to do in order for this one to not calculate at each frame. There should be an option to disable this mark here. Forgot. Does anybody know? Actions, display, render, no, load, lock, YFS display. Okay, so time dependent. I want to make it disabled. How do I do that? Can't let me search for it. So okay, network editor options, time dependent. Okay, so this node changes based on the current frame. For example, it might have keyframe animation, or it might, right? So how do I change this? Might have keyframe animation, or it might have an expression that uses the current frame or time. Display option. In the network editor, choose view display options. Badges. That's not what I really want, does it? Okay, maybe right here. Yeah, I think I did something in order to disable this auto update, but I'm not really sure what I did. Alright. Oh well. Auto generate, nope. Visualize, scene, emotion. I am not really sure. Show current if I couldn't find it, I'm just gonna file cache it for now, which is not really what I want. Show current. I thought there were some options to update or not. But if I have a new cameras here, I guess it doesn't really change. Let me just check what's inside here, if it's using any kind of frame related values, maybe in this Python. Well, let's just cache it for now. I am going to make this 50 again, and I'm going to use the file cache for the result for the wave function collapse, and then set it to current frame. I'm not going to use the frame value here, just name the file name here, and then save this and load this. Okay, now I can freely move the frame. I'm gonna check it later. Now I am going to create a primitive triangle to access to the window information and set some color animation. Now it might be better if we have started all the values, all the colors starting from the black file. So let's disable this one and set all the colors to be black. Alright. Now let's create some simple code to slowly show up the window light. Alright. Okay, so I'm going to use the random to choose the random window positions, some constant value here, plus or smaller than some ratio. And if this condition met, then I'm going to set the color for the window to be white. Okay, so let's also promote this value. Now I can use the sliders to change the how much windows I want to be able to show up or light up. Now at this time I can make this background to black or dark. Alright, now that looks good. Okay, now let's animate this value, this itself, using a frame value. So ff, the current frame divided by the frame end, will create a value in between 0 to 1 using these frame values. So if I play it, it slowly shows up every window lights being colored. Finally, it will finish by showing up all the window. But if we show up all the windows, then it looks a bit too artificial. So I'm gonna clamp this final value to like 0.9 or something. So what I'm going to do is to clamp this ratio value, which is from 0 to 1, to say 0.01 to 0.9. So this is going to be the last. So some of the window is still not showing up, but looks better. And also let's set the frames a bit smaller so the animation's a little bit faster. Alright, like it. Looks good now. And if I wanted to change the pattern for the window size, I think I need to change the seed. So let's have this changed with the seed value. Seed for the extrusion. This one also, but plus some constant value. Okay, now if I change the seed, I can see different types of windows. Okay, so the base setup is pretty much done. This is the base setup that I wanted to create. Now what I want to do next is, there are several things that I want to do. First of all, I have used this initial grid as a image file, which is okay, but to make it a bit more flexible, to make it more procedural like, I would like to make it just within Houdini to replace this texture value or texture image. Now another thing that I want to do is to combine some of the grid horizontally for each of the building to create a longer window on horizontal direction. Right, so let's do the window part first, which is not that hard to do, I hope, but do still need some coding here. In order to deal with the number of windows here, or the size of the horizontal value, we have to go back somewhere around just before this extrusion, so somewhere around here. Now it's shown in blue. Now the reason why we have so many numbers grid is because of those number of points. So by dissolving some of the points, we'll be able to have a longer edge lengths, and as a result you'll be able to have a longer horizontal window size. So that's what I want to do. Delete some of the points which is on the side, maybe using some threshold to do together with some random values for each of the faces. And one thing you have to be careful is that you don't want to delete the points on the edge, the bounding edge, right? So one of the way you could think of how you could retrieve only those points which is on the side is to get 3 continuous points first, like this one, this one, and this one, then calculate the dot product between the 2 adjacent points. So the first vectors that you want to create is the one going from here to here, right? And the second vector is going from here to here. And calculate the dot product between those 2 vectors, and if the result of the dot product is close to 1, meaning it's aligned in the same direction. If you have these points as a 3 points, 1, 2, 3, then if you calculate the dot product between this vectors and this vectors, the result will be equal to 0. So that means the point is on the corner. The middle points from the 3 points is on the corner. But otherwise, you should be able to get 1. So in this kind of square grid block, you'll be able to get the value either 0 or 1 for the dot product. So we can use that information to retrieve the points on the side, and just for the points. Just for those points, we could try to remove some of the points using some threshold. So let's do that. Okay, and I'm going to name this as simplify. Using, I want to do this for each of the primitives, so let's say let's use primitive attribute or primitive rango again. Simplify. Right, so let's do this. Another code. So first I'm going to access all of the point from the primitive using prim points, prim num, and since we need to access the 3 adjacent points, I'm going to loop the points first and get adjacent 3 points. The first one is at the index I, the second one is at PTS I plus 1. Now it should, the square should be looped, the point number should be looped, so I should calculate the modulus, and PT3, which is the third number, so in this case I plus 2. Do the same, remain calculation. Now that I have a 3 adjacent point, only if those points are sorted and the vertex order, but hopefully it does. If not, we can use a sort node beforehand. Now let's also retrieve the point position for each of the point. Do the same for position 2, position 3, and calculate the direction between the first point and the second point, and the second point and the third point. So position 2 minus position 1, and I'm going to normalize this. And another vector, normalize position 3 and position 2. Okay, now we need to now calculate the dot product between those two vectors, and if this dot product is close to 1, then that means it's on the side. It should be on the side. So let's see if it's true. I'm going to condition say if the dot product is larger than 0.5, then remove all the point. And if we could remove all those side points, then this condition is successful. Okay, apply. Now doesn't seem like it's working. Okay, only the corner point has been deleted, and let me think why it is. Okay, first of all, let me check the order of the point by showing up the point order, and if it's correct. Okay, now there is a problem because it's not in the correct order. It's not, the order of the point is not based on the vertex order, so that's a bit of a problem. So we need to fix that. To do that, we can just use a sort function or sort node to sort out the point based on the vertex order. Now let's see, still have some problem here, so let me check the point order. Now the point order looks good now, but there's still a bit of problem here, so that means I guess I have some something else to do. Alright, let me check. So let me open this up. Open up the code editor again, and let's see. All right. So prim points is the points from the primitive. It should be good. And I'm retrieving the point number I plus 1. That should also be good. And the direction, I'm also getting the position for each point. And what seems to be wrong here? Okay, I'm currently inside a primitive number right here, right? And let me check if I have retrieved this point number correctly for each primitive. Okay, apply. Let's look at the primitive attributes. Okay, that looks correct. That looks correct. All right. Now, also, let me check the length for the point. Apply this one. Okay, this one also looks correct. Okay, so what if I do this dot product in the other way? I mean, okay, now all right, I know the problem. That's because I'm using this at ptnum inside a primitive wrangle. That was the problem. Okay, gotta fix this. This has to be the one that I want to delete. So the condition should be correct. The one that I wanted to delete is the middle point from these 3 points, so this pt2. So this should be pt2. All right, now I think it worked. All right, that looks good. Now I don't actually want to delete everything, every side points, but I actually want to delete some of the points to keep the window size varied. So there's another random values you could create. So inside this condition, I can have another condition saying if random at p plus I multiply by some constant value plus some seed parameter is less than some another threshold value, let's say simplified threshold, simplify, then delete the point. Right, now let's promote those parameters that I've created, one for the seed and one for the threshold. If the simplify is set to 1, all the side points will delete it. If it's 0, all the side points will be there. All right, but looks good. Now just by doing it and accept and go back to the extrusion, you kind of be able to have a longer horizontal window size at some point, at some places. If you go back to the coloring, now it looks like these. And if I change the simplified 0, back to normal. But if it's going to be if I make this larger, then you have more bigger horizontal size windows at some of the places. which makes the nightscape visions a bit more interesting. Right, let's keep this to like 0.4. Right, looks good. Now at this point I might want to, I mean, I can go to the procedural plan now, but I might want to change the size of the layers as well for each of the building to make it a bit more varied. So I can go back to the extrusion and check where I have set the height, which was right here. So what I can do is to just change this value to some random related values for each building. Now I can create a random value for each building. Maybe create a layer height scale value using the random, again using some seed value. No, the random creates the value from 0 to 1, but let's say I want to keep the height of the layer to be 1 as the default value, and just by multiplying it with some scalar value, I would like to change some values in between 1 to some upper values. So let's say let's fit or remap this scale, the random value from 0 to 1 to 1.0 to 1.5, and multiply this value together with this n value here and see what happens. Now some of the building has more higher layers, some of the building has smaller layers, smaller height layers. Just a bit of change, but makes this a bit more interesting. All right, now maybe I might want to parameterize this scalar value as well. So CHF max layer height, and set the range from 1 to 2. Okay, all right, looks good. Now if you then set it to 1.5 as a default value. Okay, so now is the time to go back to the initial step to replace this texture value with a procedural tiling grid. Okay, now before doing it, can I just check this one back again, if I can do this without updating for each frame, because I think there are a way to ignore this being updated for each frame. Okay, there should be some options somewhere. So I'm going back to this one and disable this file cache. Oops. It's going to calculate something. Now, the reason why it's updating at each frame is because of this time dependent, and each of the node has this. Okay, I think this is the problem here. If I look at this WAF FC initialize to, which is loading the texture, this itself is time dependent, so I guess this node is the reason why it's making this update each frame. And I don't have any idea why this is time dependent. Doesn't really make sense, does it? Well, but we are going to replace this with the procedural grid, so it's not a big problem, I guess. I'm gonna make this file cache for now, and let's try to replace this with a procedural small grid, which looks like these. Okay, so what I'm gonna do is to do some simple like recursive divisions for the grid, for the plane. First I'm going to create a grid like this, and then pick an edge first, one of the edge for this square, and then let's say I pick this one, and next what I want to do is to pick the points on the edge, use some random values, let's say this one here. Then if you pick the points on the edge, what I'm going to do is to create the perpendicular line with this edge to the corner like this, and using this line to split the polygon into two. Okay, now what I'm going to do next is to, for each of the primitive, I'm going to again pick one of the edge. For this primitive, let's say I'm going to pick this edge right here and pick this point, and do the same process here. For this primitive, let's say I'm going to pick this edge here and do the same process like this, and keep doing it to split this polygon with some criteria. Now I am going to check the size of the lengths and the area. And if the size of the edge of the length and the area is at if it's too small, then if it's too big to then keep splitting, but if the size got too small, then just stop the splitting, then go with the final output. So I would like to have this kind of limitation to set the smallest edge size and smallest area size to keep the boundary, to keep the splitions, so that we don't have this kind of too small edges squares, which we don't want to have it as a building layer or building block, right? So let's do that. We can do this in single primitive layer or attribute layers or attribute wrangles, or we could use a for each feedback loop. In this case, I'm going to use the for each feedback loop because there is some useful functions for the polygon, like polysplit, to split the polygon really easily. This one. Okay, so I'm going to use the for each number loop, and I'm using for each loop right here because these operations are not going to be animated, so that's kind of the reason why I also would choose the for each loop. If the part that we're going to process is going to be animated, then I think it's a good idea using a wrangle node using Vex, because it's faster, right? But for these one, this is just the preparation part, so we don't need to care about the kind of a speed of the process that much. Now first of all, I'm gonna set this to a feedback loop, so let's set this to feedback each iterations, and then set this to fetch feedback, and start with a initial grid size without having any grid lines. So set the columns and rows to 2 by 2, and also let's be able to set the size of the grid. I am going to say it, let's say I want to create a grid 20 by 20. Okay, so 20 by 20, and let's also create a null controller at this point to store the parameter that I want to store. So okay, so the things that I'm going to explain now. Oops, forgot to change the window here. Okay, I think I'm not seeing the comment anymore. I'm not sure if anybody is still watching here. Well, I'm not sure. Maybe not. Let me check if there are any comments being created. Okay. Maybe not. Okay, I might. Okay, there might be no one listening right now, so I'm just gonna go in my pace. Alright, so where was I? So what I wanted to do is to use this for each loopback feedback loop to create a splicing for the polygon, and I have just set the for each number for the for each end node to make it feedback each iterations, and for the for each begin I'm have set it to fetch feedback, and I have also created this grid 20 by 20 and rows and columns 2 by 2. Now I want to be able to control this size using some parameters, so let's create a parameter like the size integer. Let's say maximum is 50, and let's start from 20 and copy this one, paste it right here. Okay, and put it in here. Now let's do some split. Now first of all, as I said, I would like to pick one of the edge from the square, so let's do this. What I'm going to do is to create the splitting line, I'm going to do another loop or the wrangle. Okay, I'm going to use the primitive wrangle, and after one loop you'll be able, currently for the first loop you have only one primitive right here, but after a second loop you're going to have more primitives output from here, so I want to deal with each primitive independently. So I'm gonna create another loop here, which is for each primitive to deal with each primitives, and for those I don't have to make it as a feedback loop, but keep it as a merge each iteration. Alright, Now for each primitive, I would like to create a splitting line, and let's do that. And I do need some random values to define which side and which point position on the edge. So let's have this iteration value from the first loop, maybe from the second loop as well. So going to click this one, create a meta import node, and connect this one to the third input. Right now, let's call this divide. All right, now let's first of all, I'm going to retrieve all the point numbers. Like this. And I want to make sure that the point is either, and the point order is either clockwise or counterclockwise. Okay, have to be 0. Now in this case, if you start from the original grid like this one, the point order is not like I want. If you show this point number, it starts from 0, 1, and goes diagonal places and goes 2 here and 3. But I actually want the point order to be clockwise or counterclockwise because it's going to be used for in this sample, in this case. So first I'm going to sort the point order. Maybe I should do it inside a loop somewhere around here and do the point order based on the vertex order. Now the point order has become clockwise. Now that's good. Now let's go back to the divide function and let's see what I could do. First of all, I can retrieve the random side numbers, but actually I do like to set some criteria which side to take. Okay, so if we have a square like this and we have a splicing like this, and if we are working with this primitive and this primitive, then I would like to get the longer edges than the smaller edges. If you take the smaller edge to pick one point, then you'll have more linear or more narrow polygon be created by splitting the polygon, but I want to avoid that. So I would like to get the longer edges to create the splitions, to create this split. In this case, this one at some point right here, to make the size of, to make the shape of the squares become not too narrowed. Now it's based on your preference, but that's my preference. All right, now let's do that. So where was I? So that's kind of the reason I also have reordered or sorted out the point number. Okay, so in order to pick the longer edge, I first need to get the point position, each of the point position, and then calculate the lengths for each edges. So I'm first going to create the array for the positions. And access each of the point. And retrieve the point position from each of the point number and append this value into the vector array right? Now, after I have created the vector array, I'm going to access each of the vector positions using another for loop to calculate the edges. To calculate the edge, you need the neighboring point numbers, neighbor point number or adjacent point number. So the first one, positions at I index, and by retrieving the second point position, which by using the I plus 1 as an adjacent point, and since this is a looped polygon, I'm going to calculate the modulus like I always do. Now I have 2 points, so I can calculate the lengths between those two. Let's call this L, and calculate the distance between the position 1 and position 2. Right. Alright. Now I can maybe I can have another array to store this length value. And append length L. Now I would like to get the longest value right here, right, from this length. And since this is always a square value, but maybe not, there might be well, yeah, since we are only dealing with the rectangle right now, so we only have 4 sides, okay, and meaning there's only 2 different lengths sides. One is smaller and one is bigger, okay, and that is stored next to it inside the lengths array. So if you have shorter lengths in the first index, then the second index should have the longer value, right? Or vice versa. If you have the longer value in the first index, and the second index will be the shorter, right? So keep that in mind, and let's have an integer called index to define which index to pick, which edge index to pick, and then calculate or get the conditions. If the second index inside the length is bigger than the first index, then I would like to use the second index, so update this index to 1. Otherwise, keep it to 0. This condition will enable you to choose the bigger or longer length edge index. Right, now that I have chosen the longer index, longer edge index, I can now create a random point on top of this edge to create a perpendicular line. Right. So next thing, I need to define the random position on the edge. So let's create this random values for float. Let's call this W, and let's also have this as random numbers. And I can create some seed using 2 iterations from 2 of the method node for each loop. So from the first loop, I can get the detail attribute for iteration. Also from the second loop method node, can get another iteration value, and then use those 2 values with some constant value, with some seed parameter you can set by yourself. Okay, and let's also promote these parameters. The seed value, you'll be able to create a random values for it, which is different for each iterations for the for loop. Now, the range is currently in between 0 to 1, so I would like to make this in between some minimum value to maximum value. Since if this random value is equal to 0, then the point comes here, which creates a really narrow line, which we don't want that. So let's clamp this value using some well, first of all, let's fit this value. Maybe clamping is okay, or let's use fit instead. Since it's from 0 to 1, I'm going to set the range from some defined parameter to 1 minus the same parameter value. So if it's 0.3, then it's from 0.3 to 0.7. Alright. Apply. Show up the parameter W. Alright. Okay. Now we can now use this value to create a random points on the edge. So let's do that. To create the random edge on the point, we need to have 2 points, which creates the edges. So we can refer to this index right here and get the point position. So the first point position will be, let's name this 1, 1. 0.0 p at index, and the second point position, let's name this 1, 2, is index plus 1, and again this is a loop polygon, so if it gets more than 4, I have to make it back to 0. Okay, so now I have 2 points. Now what I want to do is to calculate the point position in between this point with, let's say, this one here, and this point, say this one here, with the ratio of this W. So if it's 0.5, then that's on the middle. If it's 0.3, that's on somewhere 30%, and so on. Alright, so the final point position, let's name this one pos 1m, is pos 1 1 plus pos 2 1 minus pos 1 1 multiplied by W. Okay, and finally I'm going to add this point. pt1m is equal to add point 0 pos 1m. Alright, now I have errors here. Where is that? 33. Pos 2 1 is undefined. Okay, should be 1 2. Now I see 1 points being created on the grid. And if I change the seed, I should be able to change this point position randomly. And by changing this W, I can set also the maximum minimum of the point position. Alright. Okay, let's keep this to 2.2. Alright, so next thing I'd like to do is to create a perpendicular line which connects this point to the other slide. So to do that, I need another point information right here using these 2 point information and calculate the other corner's point. That's pretty similar to what I have just done here. I'm going to copy all these And let's name this 21222M and 2221212222M. Now I think I need to change one thing here, which is the order. Since we are calculating the point in clockwise order, the first one right here was using this point as the first point and this one's a second point. Now for these ones to use the same value W, I need to use this one as the first point and this one as the second point to use the same W to calculate the same position on the corner, the other corner's point position. So we need to change the order of all the point here. So for this one, for the position 2, 1, this should be equal to this one. And also I need to add 2 for each of the point index. So if it's 0, then you have to add 2 to get this point. If for this one to add 2, you get this point. So I am first going to add 2 to the index, and for these one, both of them need this modulus calculation. For this one, it becomes 3. Now I need to make this index comes right here, and this index comes right here. And as a result, you'll be able to create the other side, other corner's point. Now let's check this by changing the seed, and all the position of the newly created point, it corresponds to the other side. Alright, now that I have 2 points, I can just connect these together to create the line. So add prim 0 polyline pt1m and pt2m, like this. Did it show up? I am not sure. Yeah, it did. Okay, so, and finally I only need this line, so I'm going to remove the original primitive. Alright, so I have just created the splitting line here, and previously I have this polygon here. So by having this polygon and splitting line, I can use the node called polysplit to divide or split this polygon into 2 using the line. And let's have this right here. Okay, and since this is a feedback loop, if we do this, can do this 10 times, you'll be able to split like this recursively. And as you can see, some of the faces become too small, obviously, so next thing we need to do is to set some limitation. What will be the minimum size for this final square or final rectangle? Right. So let's do that next. So I would like to set 2 limitation. One is the side lengths for the square or rectangle, and one is the area for the rectangle. I mean, maybe just setting the side lengths is enough. So let's do that first. So to get the side lengths, I'm just gonna make it really easily by first of all convert it into line using convert line node, which converts each of the polygon into a line. Okay, I think I need to go back a little bit. Let me make this feedback loop to 1. And also let's connect this right here so that we have this simple node here. And if we do this convert line, I am converting each of the primitive with these a bunch of lines right here. Now, okay. And what I want to do is to check the lengths of the splitted polygons edge using convert line. By using convert line, it just changes each of the edge with the lines, and it also has a parameter called rest, or attribute called rest length, which is the length for each of the edge. And we can check these to see if the minimum value of this rest length is within the limit that I have set. Okay, so I need to set some limitation for the lengths. So let's create some parameter here and a null controller. So minimum rect lengths. And set the range from 0 to 10 for now. Let's set it to 5. Okay, and copy this parameter. And so in order to check if this length is smaller or not, the easiest way I could think of to get this minimum value is to first use the sort for this primitive, the line primitive, using the attribute, using rest lengths. As a result, the first item you get, the first index you get for this primitive has the shortest length right here. Now I can maybe store this and connect with some null node, like sorted lengths, and use the switch node to connect this connect the splitted polygon to the first input, and unsplit it, the one that's not splitted yet, to the second input for the switch, and use the condition together with the shortest length of this edges together with the parameter that I have set here to see which node, which output should I use. Okay, so if so the condition should be, first of all, let's retrieve the rest length from this sorted length, the first primitive attribute rest length. So prim sorted lengths at the 0 index, and then the name of the attribute is called rest length, and 0 is if it's let's say if it's smaller than the limitation, then you don't want to use this polygon, so you use the original one before splitting. So make it smaller than the one that I have copied from the parameter, which is the limit value. Okay, and connect this one here. Now let's see if this works. So I currently have this 5 as a final, the shortest edge length limitation, and if I raise this iteration up, it stops at some point. So if I keep this to 10, even if I keep this to 10, it stops at this point, which is because each of the edge lengths is already close to 5. Let's check this out. I do another convert line to check each of the the shortest edge lengths, and the shortest is currently 5.0, so I guess it does make sense. Okay, so but 5 seems a bit too big for the limitation, so let's make this a bit smaller. Now you start to see more split or division. Let's make it 2.5. Looks good. Right. Now, so let's say I'm good with these division. Now, next thing I would like to do is to use this information to create a grid like this, which is a 20 by 20 point grid. And at each point you have this color attributes and the name attribute. And the name attribute is based on the color value as well. So if the color is 111, then the name is also 1_1_1. If the color is black, then 0_0_0_0. Okay. So let's try to create the same structures procedurally out of this output. Okay, so one that have the edges, I want to make it white, and one that's inside the square or rectangle should be black. Okay, so first of all, I need to have a 20 by 20 grid points, and I can create that by having another rectangle or a grid node, and let's copy this size value and this time use it for rows and columns. Rows and columns. And if I look at this number of points, it looks good. Now let's also set the size of this grid corresponds to this point right here, which this one is also 20 by 20. Now this is actually small, so I guess we could use this same size value for the X and Y value. Alright, now I think, and maybe I can use the center of this primitive as the point position, but it seems like it's a bit offset compared with the original grid point, which is this one. You see there is some offset here, and that is because, let's say, actually I want to convert this primitive to a point. I'm not going to use the edge of this primitive as a point value. So to make the number of primitives 400, I think I need to raise the rows and columns by 1. So +1, +1. Now it aligns correctly. Okay. Now looks good. In order to convert this primitive into a point with the attribute, I can use a primitive wrangle. Init grid, and first of all I'm going to add a new point at the center, which is at P. Okay, which I've created the point, and I don't need the primitive faces anymore, so remove it using remove prim, like this. Okay, now now that I have those point information right here, I could relate this together with this how do I say, the grid that I have created. Now if I look at carefully right here, by showing the ghost of this grid and with these lines here. The line is not really on the grid, actually. But we can kind of estimate this grid position. And what we want to do is to draw this intersected grid point with a white and not intersected point as black. Okay, so to calculate the intersection between the grid face and the line, if it's, we know that it's a square grid the size of 1 by 1, so the easiest way is to just calculate the distance on the horizontal direction and the vertical direction to check if it's within this square or not. To calculate the perpendicular direction, you can just use the projected distance, a minimum distance between the point and the line. In that case, we could use either a function called min-pos or xyz distance. Now let's use xyz distance because you can also retrieve the primitive number as well. Okay, so let's do a point wrangle, and this is the one that I want to convert the attributes, and this is the guide to check if there's an intersection or not. Now I know that the grid side is 1, so I need to check whether the distance between the point and the line is within 0.5. That's the gold number here. So first of all, I am going to calculate the distance using xyz dist from the second input with using the current point position, and then if the distance is less than 0.5, then that means the point is close enough to the edge, which in that case you want to set the color of the point as white and set the name of this point attribute to 1_1_1. Okay, else set it to black 000 and the name to 0_0. Oops, 0_0. Okay, how's it? Now let's check. It's a bit hard to see if there's any changes or not. Go into the geometry spreadsheet, and there's a color for 1 and there is no color for 0, so something is wrong. So let me check the distance first. For each point, distance, okay, everything, the distance is set to 0, so this one is wrong. Okay, well, I was calculating the distance with the polygon, so that was the problem. So let's convert it to line first. Convert line, so like this. Now I should be able to create this edge of the point which is on the edge to be white and the one that's inside as black. Okay, now it looks good. Alright, so init grid 2. Okay, so I think structure wise this one, which was using the node called WFC initialize, and this one made it procedurally have the same attributes. Well, I don't need this distance attributes anymore, so let's delete this. So it should do the same. It should do the same things. So let's try to replace this with this one and see if this still works. And the good thing about this one, it's not time dependent, so it's not going to be updated by changing the frame. So, but this one was somehow time dependent. I don't know why, but that was making this solver for wave function collapse being updated every frame. Okay, now let's open this up and it seems it's working, so that's good. And if I change this frame, nothing changes, so that's also good. All right. Now, going back to the initial state here, which is this one. Let's try to change some parameters to see the differences, difference of the output from this procedural grid. Now I'm going to delete this one. Maybe I'm just gonna keep it somewhere else. And let's set some parameters, like set the minimum leg length to smaller, like having a lot of grid opening like these. Okay, and it's a bit hard to see what's going on here, so I would like to create a visual guide with the rectangle. And set the grid size to 1 by 1, grid 2 by 2, so that it's easy to see what's going on here. So currently we have a lot of small squares, and let's see what this what kind of grid widths will be created using the wave function collapse. Now by using it, you have a lot of small squares right here, and as a final output, now we can delete this file cache. As a final output, you see a lot of small building, which is small enough that I cannot really see here. Which is still interesting, but let's keep the size of the edge a bit bigger, like having more than 2 pixels. So going back, and let's raise up some parameters. Okay, maybe 2.5 is a good number here. And we could also try increasing or decreasing the total grid size here as a sampling. If I make it 10 and make this like 2.0, let's see what kind of patterns it will create. It creates more generic, more constrained grid. If I make it the 30, you have more randomness appeared. If I set it to 40, not much changes. 20, still good enough. So let's keep with 20. And let's also raise this min rectangle up a little bit. Now it looks good. Now, at this point, which is working just fine, but I would this will create a procedural like grid like I want it, but I would like some additional like constraints to the original grid, the procedural grid. Like just making the square grid is actually not that interesting, is it? I don't think so. What I want to make is some part to be L shape, some part to be more irregular size, not rectangular shape. So that's the final step, what I want to do here, which is the last step I'm going to explain. and it's already been 3 hours, so you can leave at any time. I know it's a really long one. I'm just doing it for my interest. Right, so let me explain how we can do that. But you can just finish at this point. I mean, basically it does what it does this point, but I'm just adding several constraints to make it a bit more interesting to me. Right, so going back. Right, let me check. So what I'm going to do is, after I have created these square grid or rectangular grid, what I'm going to do is to randomly pick some rectangle out of this list of primitives and get the adjacent primitive. Like for this one, get either this primitive, this, or this, and then connect them together to create as one primitive, and continue doing that for other primitives. And it might make sense to choose from the smallest area for each feedback loop. Okay, so that the smallest becomes a bit bigger, and then again for the next loop choose another smallest group to make a bit more bigger. Right, so let me do that. So let's keep this as one set here. Maybe I'm gonna group this out. Then create another for each loop, another feedback loop with a number. Let's set it to fetch feedback fetch iterations, and this one to fetch feedback. All right, and then connect this one right here. Okay. Now let's think how we can deal with it. The first thing I would like to do is to get the minimum, get the primitive which has the minimum area size. So first I'm going to calculate the area using the measure node like this, and then sort the primitive based on the area. And after doing it, I am going to split the primitive the first output. I want to get the minimum polygon, which is in this case this one, and from the second input I'm going to output the other rest of the primitive. Right, and what I'm going to do is to find a adjacent primitive for this smallest from this these primitives. So in this case either this one or this one, right? And to do that, to find out the adjacent primitive, what you can do is to retrieve the point position of this primitive, then check the distance between each of the primitive within here, which is in this node, and then get the, if the distance is 0, then that, if the distance between the points and the primitive is 0, then that is equal to either this primitive or this primitive. Right. And then randomly choose one of the primitive. So let's do that. And to do that, again, I am going to use another point wrangle. So for the first primitive here, second primitive here, I'm gonna call that rest, and check closest. Okay. Now well, maybe I should use the primitive attributes, okay, a primitive wrangle, instead of points, because I'm only from the first input I only have first primitive, and I'm going to calculate the closest distance using all those points on the primitive. So first get all the points, and loop through the points. This and get the point position. At PT, then calculate the smallest or shortest distance, closest distance between this position and second input using the XYZ distance. XYZ dist and one at position. Now I also would like to retrieve the primitive number for this from the second input, like which primitive was the shortest in the shortest position. So I would need additional output parameter. One is the prim, one is the UV. So the third parameter is prim, and the fourth parameter is UV. And the prim will be updated to the primitive number from the second input, which is on the shortest distance. Okay, and then I can create a condition. If the distance is small enough, which is close to 0, then let's use this primitive. Now I could create an array, int prims, to store this number of primitives that I have found, like this. Okay, now that I have a list of primitive which is in the array, I could get the random numbers from this array. So first int random prim is equal to prims, and inside here I can create the random index based on the point position of the primitive using some seed value again, and maybe using the iteration value as well. So let's connect this one to the third input and retrieve the iteration value in detail second iteration, and okay, now, and since this is 0 to 1, I have to multiply it by the length of primitive, and finally make it integer value. I'm gonna make it as a floor value. Alright, now I should be able to get a random primitive number from the array which is adjacent to this primitive. Right, so next thing I am going to do is to actually retrieve that primitive number, right? This primitive. So let's set this as a integer attribute to this primitive first. So at our prim is our prim. All right. Now, next thing I'd like to do is to retrieve the primitive from this right here. So I'm going to create another null node, name this min prim, and then I'm going to create another split node for the rest and get the primitive attribute from this one, our prim. So our prim min prim our 0 no, 0 r prim 0 is actually the one that I want to retrieve. It's not adjacent, is it? What's wrong with it? Okay, something is wrong, which is not in the distance of equal to 0. Okay. Let's see why. Let me also have this prims. Okay, well, let's see. Let's have this prims attached as an attribute for this one. Let's check this out. Okay, something must be wrong here. Why do I have every... but might be okay. If I look at this primitive, okay, well, obviously it's not correct. It is not correct. I should be able to have 7 or 8. Is it 8? Yeah, 7 or 8 for this list, but I have 10 for all of them. Now, why is that? Why is that? Let me check if this one... well, this has to be 0 first of all. Let's check. Okay, it's still wrong. So I have retrieved the point position from the primitive and calculated the shortest distance. Let me open up the Houdini Vex functions. To check the XYZ distance functions, if I'm using it correctly. So I think I was using this one, geometry, origin, prim, UV, looks good. Now, and prim points, that's fine. Wait a minute, what's this? I should be doing like this. I am getting the point from the index I. I was calculating the lengths. Obviously that was wrong. Now I have 7, 7, 8 and 7, 8, so looks correct now. Okay, that looks good. So this point is close to 7, this point is close to 7, this point is close to 8, so this seems correct. Now I have retrieved the random values from one of the array, in this case 8, and as a result, using that 8 value, I'm still retrieving something weird here. So I'm using our prim, and this I'm using maybe I should make like this. Okay, now it looks correct. Yeah, I needed this backslash here, more back quote, to make it able to use this expression in the group filter parameter. Alright. Now I think it's retrieved fine. Now what I want to do is to merge these two together and then make it as one single polygon right here. Okay. To do that, I mean, in this case, this is pretty easy because the point is being at the same positions, but there is a possibility that the point doesn't match. Like you have one rectangle right here, one rectangle right here, somewhere like this. In that case, you cannot use like a fuse node to merge those points together with the divide node. but you have to think about the other way. Now, what I have found out is to use first of all, triangulate 2D to calculate the Delaunay triangle using all those points. This is actually not a good example to show why I'm using this one. So let me change the initial values by changing the seed here. Let me also create the seed value. Range from 100 to 0 to 1000. Copy this one and go to divide node where it has a seed parameter here. Paste it right here. Okay, now let's check until we have a connection which has irregular shape, which sometimes is not L, but sometimes more like a pier shape. So, oops, okay, did it again. Alright, now I hate this thing. When we reopen this file, Now, I'm not sure if I have saved it, but there's a temporary file being saved, so I'm gonna open this one. Okay. So, this one has been picked, and the one that has been picked from here is this one. It's still a rectangle. Not good. Not good. Let's change the seed again. So now how's this? So this is, oops. Let me change this to 0 now. Okay. Okay, why I'm not seeing it? Because I am not getting anything here. Let me connect this one to right here for now. Okay, and let's also make this one. Okay, this is not good. Okay, so this might be a good example showing size differences here, but let me also see a more irregular shape like this one. Yeah, this might be a good example. So I still want to have this concave wrapped geometry out of these two, and meaning I would like to get the silhouette of these two geometries. Now unfortunately we cannot use this fuse because the point is not on the same positions, and we cannot use like the silhouette labs extract silhouette from the SideFX Labs, because this only works if the point is fused, I think. If I try to use this for the Y direction, it seems like it but does it work? Seems like it's working, is it? Oh, it did make it as one primitive. Okay, so probably using this extract silhouette might work after all. Let me check with other parameters. Last time I tried it didn't work. Okay, so this one doesn't seem to work with this. Not sure why. So this one keeps as two primitives somehow. Even if I fuse it, or if I unfuse it, I still have two primitives. This extract still it doesn't seem to work. Not sure why, but so there are cases like these. So in case I want to merge these together as a one silhouette or one polygon, one primitive, what I found out is to use this triangular 2D first to create a Delaunay triangulation. Then this will create a convex geometry out of all those points. And what I need to do next is to delete the additional triangles being created, which is not on the original polygon shape. So to do that, I am going to use the primitive wrangle for each of the faces together with this on the second input, the original polygon to the second input, and check the minimum distance between the center of the polygon to the original polygon. And if distance is 0, if this distance is close to 0, then that means the triangle is on the original polygon. If it's not, then the triangle is outside this polygon. Then that for those polygons you can delete. So do another calculation for the distance, xyz dist at p, and if the distance is small, bigger than 0.001, meaning if it's not equal to 0, then remove prim 0 prim num 1. Okay, now I can use the divide node to delete those edges inside with this option, remove shared edges. Okay, and this will create what I wanted. Okay, that looks good. And what else? That's pretty much enough, and connect it to this feedback loop. All right, and I think I'm missing here because since this is a feedback loop, I need to merge this one with the rest of the primitive, which is coming from this node output, second output for the split. So let's check this out. Yeah, that was it. So combine these with merge node. We don't really care about the direction of the normal because we're going to convert it into line later, so it doesn't really matter about the direction. Okay, now we have created this irregular shape, and by increasing the iterations, we can have more of these irregular shape by adding the adjacent primitives. And then we can convert this into a line using this one right here to create a more irregular shape. All right, now I think having this iteration as a parameter is also a good idea, so let's have that. Let's name this combine iteration. Okay, it's with L shape, and diagonal shape might be interesting. Yeah, maybe having diagonal shape might also be interesting. Let's try that next if I have time. Alright, so for the combined iteration, I'm gonna set as 0 to 10. Should be enough. So let's copy this one to right here. So if you want to only use squares, you can keep the combined iteration to 0, but if you raise this up, you can have more irregular shapes. And together with the seed value, you'll be able to create several different shapes. Now if you want to avoid creating this kind of like pier-like shape, but only want to have a L shape like these, you can have more conditions inside here when you are checking for the adjacent primitives, but I'm not gonna go through that. You can, if you want to do that, just try going here and do it. Change the conditions right here. Okay, now what else I could do? Now let's check what kind of geometry we will create using this setup. Like in this case, we have this kind of shape here. Now let's also change some parameters here. I think I can also copy the seed and use it somewhere inside this loops. What was this doing? Okay, this was deleting the triangle, so del try. And for the check, this what's this? Okay, let's promote this parameter seed here, and let's paste seed here. Okay, so we can create a bunch of irregular shape, more than square. So let's try with this kind of setup to see what kind of output we could get using a wave function collapse. So by using this one, we have now more L shape like squares being created. And if we show this up as a 3D, maybe showing it as a white first, it looks more like it. Yeah, I like it. Oh, this might be too small, but that's fine. Okay, so it does what I wanted. Let's also change some parameters. If I change the seed, also changes pattern. Now this creates a more like stair-like shape. Okay. Now what if we change this to something more different? Go back to this one, the guide, the initial grid, and let's say the minimum size is 3.6. Now it gives you a bit more interesting shapes like these, and let's see what kind of shapes we get out of this one. And as a result, you get something more massive, more longer dungeon-like building. It's a bit hard to see with the background dark. Alright, well, that's also interesting, and the animation still works. So after this, it's a matter of playing with the parameters, what kind of output you like, and you can test out by creating a bunch of initial procedural sample grid which has been created in this process, and then feed it into a wave function collapse node to create a bigger scaled grid. Interesting, isn't it? Now I might want to keep this to 2.6 or something, and then have more L shape. Maybe keep it L8, and then change the seed. Alright. And as you go. Alright, like it, I like it. Now if you want to have more bigger size for the output, you can go back to this WFC initialize one, which has connected to the first input of this 2D wave function. And let's say if you want to have 100 by 100, just set this 100 by 100 and recalculate it, which will create the bigger grid using the same sampling rule. Alright, looks good, isn't it? And if you zoom it up and play it, you'll have something that I have shown you as an animation. Now maybe I can remove this disable lighting toggle to make everything lit up, black and white. Alright, now let me also try with the diagonal shape if I could do it. Well, it's still in a, you still need to express it with the grid, so even though it looks diagonal, it will going to be something more like a how do I say that, stair-like shape. To make these things really diagonal, I think it's a good idea to use other colors. I mean, you can use more than black and white colors, but you can use many more colors for the calculations, for the wave function calculations. So for each colors, you can, let's say the red is right bottom direction corner, or for the blue bottom left to top right corner direction, and so on. And so use those, each of the different colors with different purposes might also make sense. I'm gonna get into that but because I think it's going to take more time. But if you do have some that kind of informations, then you'll be able to have the final outputs as a diagonal with the real diagonal geometry. The other way you could think of is to, if you have this kind of black and white layout, and you see that there's the corner information has some different information, like this one has 3 whites on the left bottom, this one has the 3 whites on the right bottom corner, this one only has black on the neighbors, and so on. So based on those states, you can replace the geometry what you want to place by using WFC, what was it, Wang tile decoder. Okay, so by using Wang divide decoder, you can set, or you can apply a new attributes to each of the point based on the relationship with the neighborhood. If you look at the geometry spreadsheet for the points, you'll be able to see a new attributes being created. Which is I'm not seeing it. Is it, or is it for the primitive? Nope. Ah, okay. Needed to touch this one. Now the name has changed from 0 to 255, which determines the neighboring relationship between the points, and you can use those values together with a Wang tile sample to place a already defined stash of geometries to replace the point with the stash geometries. So if you look at this Wang sample tile, this is just a sample which has bunch of geometries, and if you align it, it looks like these. And each of the attributes, each of the primitive has a attribute called name, I think. Primitive. Nope. Was it? Let me. Okay. I thought. Okay, so if you go to the primitive attribute, there is a attribute called name for each primitive, and this name corresponds to the name attribute for this Wang tile stick order. So you can use copy to point node using the using a piece attributes using name. You can place these geometries, which doesn't really look correct, does it? Oops. Okay, I guess that is because of the because of the alignment of the grid, I guess. Because I have made this grid procedurally, maybe the point number for the grid must be something different than the original one being created right here. So we'll look at the point numbers for the grid. Let's see where the 0 starts from. It's too big. Let's make it 50 by 50 again. 50 by 50 or 40 by 40. And the 0 starts at the right bottom corner right here. And if I look at the grid, if I look at the one that I have created procedurally, no, it does seems the same, does it? Doesn't it? Okay, well, I don't see any problems here. I just didn't copy this node in the right position somehow. What if I use this one? No, it still doesn't. Alright, not sure why. Maybe I'm doing something wrong here. Source group type, primitive. Nope. Points. Nope. Pack and instance. Oops. Not really sure. Maybe I should use the pack with the name. Oops. Transfer attributes name. Well, forget about it. I don't really use this for this example. Okay, well, let me try with the diagonal shape now. what I can do is going back to right here for the first one where I was splitting the grid, and just change a few of the code for the divide. And the place where I can change is this W. Okay, so by changing so this is the second corner, this is the first corner, and for the maybe for the second corner, let's try by adding by like 0.1. You'll be able to have a bunch of diagonal curve like these. Okay, now let's test this out together with a merge node, which creates a really irregular shape, and the final grid looks like these. Now, since if you want to have a diagonal shape, you might want to have more resolutions. Currently this is pretty low res, so as a result you get something really not wanted, something like these. Yeah, you might need more resolutions when you have a diagonal shape. So having tons of diagonal shape doesn't really make sense, so let's set some limitation. So let's say there's some random values. Is there a seed for this? Okay, so if rand and if rand eta1 multiplied by eta2 multiplied by some constant value plus seed is less than 0.1, then add or update the W by 0.1 or 0.2. Well, what was the minimum? We have to also look at the minimum value, which is this one right here. So this has to be a bit smaller, so let's say 0.5. Okay, so some of the line became curved or diagonalized, and some of the curve being straight. Doesn't really look good though. Let's say 0.05. Well, still. If I change the seed. Okay. And going in. Well, because it's pretty low res, it converted into really square grid. Now if I had set this to 30, and now if I have more the bigger size, start to have this kind of shape now. Okay, maybe I might want to have more diagonals. Let's parameterize this as well for this threshold. Okay, let's see with these. Now looks a bit better than the last one, but still not that good, is it? Maybe I should keep it as 0. Okay, so it's pretty much all what I wanted to show, and I have spent like 3.5 hours. Sorry for that. If there's anybody still watching. Alright, well, it's time to, well, give me some time to make all these parameters that I created stored inside this controller, and I'll finish this. So first of all, I think I have stored all those parameters. Okay, this one was to change the minimum or maximum edge length. So let's give it somewhere here, and min edge or ed point pos. Keep it to 0 to 1. Let's set it to 0.2 and copy this parameter. Go back here and paste it right here. Okay, now going back to here. What was the parameter I could change? I think I have all these parameters being stored. Okay, these are good. Okay, I think I can also control the iterations of this one, but I mean, this iteration doesn't really matter because it stops if you couldn't find any like bigger lengths to divide. So keeping as high value is fine, I guess. This one as well. So let's just keep it as 10. And for the initial grid, that's also good. Yes, Happy New Year. This is, yeah, December 31st, so we are ready to celebrate the year in 24 hours, at least for me. Yes, some of you lives in different time scale, so you might have a new year later or earlier, probably. For this one, okay, I can set the size of the grid as well. Let's keep this to a default value like 2.5. And which this looks a bit too small, isn't it? Let's keep this to 3 or 4. And let it 2.6 or 7. Yeah, this looks better. Okay, now the final, yeah, I could parameterize these as well, I guess. So, and I can also parameterize this one as well, just in case. So let's go and let's make a separator so that I know that I'm updating the functions or parameters for the wave function collapse. The first one is the output grid size. Well, more output size you have, the calculation becomes slower for sure, but let's keep it 100 as a maximum. And then the sampling number, so sample num. The minimum, let's set the minimum to 2 and the maximum to 4. Okay, and for the output grid, start with the 50. I mean, you could also make it like rectangular shape, I guess. Didn't try that out. Let me try this. And for this sampling, 3 is default. So keep it as 3. Now, open this up. And, oops, now it seems to create a bit more to stair-like shape. Let's see why. And that is probably there was 2 big squares right here. Maybe I needed to split more of these in order to make it more to have more smaller grid. Or you can update the sampling number to 4, which will sample the larger part of the initial grid to make it more, to preserve more original shape. Yeah, looks good, but the building is a bit too big. So I'm gonna keep it to 3 and set the minimum length size to 2.3, which creates, wow, let's keep it 2.5. That looks good, isn't it? Okay, so I like this default, this settings currently. Now, what if I change the size for the columns? Does the shape also changes? That seems so. Okay. Seems like if I change the either side of the width or rows, it also changes the pattern. Not sure why. What if I change the point from 0.6? Right. Might be because I might need to okay, wait a minute. It might need to be that the ratio of the width and the columns and the rows might need to be related to the source. That might be the reason. Is that so? I don't know. But it looks like it. Yeah. If I set it to 1 by 2. This one seems to work. This way seems to work. But if I increase the columns more and set the rows smaller, this starts to give you some weird result. Don't know why. Let's set it to just set it to square size, shall we? I guess is how it's been implemented using Python. If you look at this one, there's a Python node here, so I guess this is the one. This is the place where the SideFX has implemented this algorithm. Okay, so in terms of the parameter, this is good. What else? Going into the later node, fuse, divide, sort, simplify. Okay, so those are parameters that I could change. Let's go open up the node control again. Another separator. Oops, not the label. Not the label. Okay, and simplify. Let's unlock for a bit linking parameters, and then drag and drop these. Wait a minute, this seed can be coming from this one, I guess, but no. Since this seed also changes the output for the wave function parameter, we should differentiate this seed value, because if I change this one, then the another calculation for the wave function collapse, another solver would run, so we need another seed value here. Let's name this C2. Set the range from 0 to 1000, or I could just drag and drop this one. Drag and drop this one, drag and drop this, simplify as well. The seed, set the seed, say to 0 to 1000. Now, what else? Extrusion. So I have this power. Extrusion power. HS, this is the window. Okay, well, I don't use this anymore, so let's ignore that. Min SC. So this is the minimum scale value for the window size. So min window scale. Okay, what else? Seed. Okay, for this seed, I can just copy the one from here. So let's leave that for now. Max layer height. Okay, that's the value to determine the layer height differences for each building from 1 to this max layer, used as a multiplication value. So set the range from 1 to 2, that's fine. Okay, apply, accept. Going back to the null node, copy the seed value here, and then paste it right here. Okay, and going to the extrusion. Now, if you just want to show this as a shaded building, that might also is interesting, might be interesting. To do that, what's this? To do that, we can have additional code here. Well, first let me delete those HS and BS, which I don't use this anymore. And then I am doing this for each primitive. Okay, and for each point I can set some color related value or height related value. Where is the point creation? Search for add point. Okay, so this is the one, this is the position where I'm adding the point. So I can add a attribute to this point, like call, based on the height. So new pass dot y divided by the height was defined. Where was it? The new pass. The C pass. Wait a minute. Okay. Yeah, this right here. And using this H value. So the new pass divided by the maximum height is the one that I need, and H, that will be H multiplied by L. What's the maximum? LHS. Okay, Oops. At WPT. Oops. Still. So call set point attribute, call WPT and pos, new pos. Right. Now if you just want to have a ambient occlusion shaded color, you can just update the point color using the ramp from attributes, using color. Oops, now I think I have some issues with those points here. I think I need to look back into the extrusion. There should be other code adding a point. Okay, so this one, so set point attribute, add the same color, call attribute to this npt and pos dot w, and pos dot y divided by h multiplied by LHS. Okay, now if I hide the wires, it will show you a clean shaded building, which also looks good based on the height. Now that was the side effect, and going back to the window, and there's another parameter you can set. One of the ratio, well, ratio is based on the time frame, so we don't really need to care about. For the minimum maximum, well, I guess it's okay with those constant values. So I guess I have just done transfer all the parameters that I need in order to create this set up. Okay, now finally I'm gonna make this dark and set the size for the output to 100 to make it big enough. Alright, now some of the building looks too high, so to reduce that I can go to this extrusion power and make this lower value, like 0.8, since this is based on the area of the building. Okay, well, maybe I could have another type. Create a seed, change the seed. Whoops, that's too much. That is too much. Now this is because I think it's because you have more diagonal shape. And now this one becomes too squared grid. Now that's not that interesting. Let's go back here and see what will be the best parameter to make an interesting shape together with the diagonals. I mean not the diagonal, but with the L shape or irregular shape. First of all, what about these? I guess if we want to keep those structures more, we should increase the sample rate as well. I don't want this kind of too long, too linear stuff, do we? So first of all, I'm going to raise up the number for the minimum rectangle length to like 2.7, then minimize the value for the combined iterations, raise up some change some seed values, and then set the sample numbers to 4. I still see some small edges. Okay, now this looks good. Okay, so how does this go? Since I have changed the sample number to 4, the calculation time gets up longer, much longer. Now it doesn't look good. It doesn't look. What if I change this to 3? Does it still look? Well, no. Nope. Oof. 2.5. Looks too small to me. Yeah, it looks too small. So I should have more than 2 right here. This one looks good in terms of the oops. Okay, well, I do see a bit too rectangular shape here. Now let me also check this or allow rotation and see if this changes a bit. Okay, now it looks much irregular, but a bit better. But there's too many ladder-like shape. Let's change the sample to 4 again. Alright. Well, maybe. That's might be better. Okay. Looks too high, but I can reduce that by changing this power to 0.5. That's too low. 7.7. Yeah, that looks good enough. Okay. So well, as you can see, setting the balance, finding the good balance for the wave function collapse is a bit hard. But I guess, I mean, for me, it's the first time I'm using this node, this algorithm. So I think I'm gonna try this out a lot more for other usage. Okay, that looks good. Now finally, let me also have some additional value to this one and end this tutorial. I'm going to add some yellow light and the last, then I'm gonna finish this. So first of all, I'm going to create another random value based on point and some seed, maybe for seed for this one as well, and then loop between the white color and the yellow color, which is 110 with L, and that's it. More like a building now. Okay, that's it. What time is it? 1. 1 a.m. So I have done like 4 hours. Sorry for being so long. This is the last Algorithmic live for this year. I will plan to continue next year as well, at least until 50. This is the 42nd. And I haven't thought about if I do for the next week, since next week is the New Year's holiday, but let's see. So thank you for watching, if anybody's still here, and I am going to keep this as an archive, so you can go back to the same URL to check what I have done. And also I'm going to upload the HIP file for this one that I've just created and paste the URL to that file in the video description page so you can download it. But in order to use this file, you have to have a Houdini 18.5 because I'm using the new structure school dictionary, and as well as the SideFX Labs being updated to the latest to use the wave function collapse node. Okay, so that's one thing you have to be careful of. Alright, so thank you for watching, and if you also find this video interesting, and helpful for other videos, I have also started the Patreon myself, so it will be great if you could support me on that as well. If you feel like it, you can go to that Patreon page from the video description page as well. Okay, so good night everybody, and I hope you have happy new year to everybody, and hope you have a great year next year. Okay, good night, and